Our video tutorial is about uniformly accelerated motion. For example, an automobile and a truck start from rest at the same instant, with the automobile initially at some distance behind the truck. The truck has a constant acceleration of 2.2 meters per second squared and the automobile an acceleration of 3.5 meters per second squared. The automobile overtakes the truck after the truck has moved 75 meters. How much time does it take the automobile to overtake the truck? How far was the automobile behind the truck initially? What is the speed of each when they are abreast? And sketch on the same graph the position of each vehicle as a function of time. Take x equals 0 at the initial location of the truck. So here is our problem. The automobile is behind the truck initially. Both of them starts from rest, so its initial velocity for both the automobile and the truck is equal to 0. The automobile has an acceleration of 3.5 meters per second squared and the truck is 2.2 meters per second squared. So after the truck has traveled 75 meters, the automobile overtake the truck. So letter A. So these are the equations that we are going to use. Final velocity v, distance, and final velocity square. So for letter A, how much time does it take the automobile to overtake the truck? So let us consider the motion of the truck. It travels a distance of 75 meters. So from the distance formula, so distance traveled by the truck is equal to initial speed times time plus 1/2 times the acceleration times the square of time. So the distance traveled by the truck is 75 meters. Initially it is 0 since it starts from rest. Its acceleration is 2.2. So we are going to solve t in this equation. Simplify. Solve for t. Divide and extract the square root on both sides. So the truck takes 8.26 seconds to travel this distance, 75 meters. Take note that since the two vehicles start at the same instant and they start from rest, this distance traveled by the automobile takes 8.26 seconds also. So the same time automobile and the truck starts from rest and they start at the same instant. This distance x plus 75 is also traveled by the automobile at the same time, which is 8.26 seconds. So it takes the automobile 8.26 seconds to overtake the truck. So letter B. How far was the automobile behind the truck initially? So this is the distance d sub a for the automobile using the distance formula. This distance d sub a is equal to x plus 75 and it is equal to this equation expression at the right. The initial speed is equal to 0 since it starts from rest and its acceleration is 3.5. T square is 68.1818. We will solve for x in this equation. Simplify. Solving for x, so x is equal to 44.32 meters. So initially the automobile is 44.32 meters behind the truck. Next, letter C. What is the speed of each when they are abreast? So using the speed formula, final speed, the speed of the automobile is equal to initial plus acceleration times time. Initially it starts from rest, so it is equal to 0. Acceleration is 3.5. Time is 8.26 seconds. So the automobile is traveling 28.91 meters per second, while the truck, the speed of the truck v sub t equals v sub o plus acceleration times time. Initially it is 0 since it starts from rest. Acceleration is 2.2. time the same, 8.26 seconds. So the truck is traveling 18.17 meters per second when they are abreast. Next, sketch on the same graph the position of each vehicle as a function of time. Take x equals 0 at the initial location of the truck. So let us derive the equation. Let us express the distance in terms of time. So for the truck, initially it is 0. Initially it starts from rest, so it is equal to 0. Substitute acceleration equal to 0.2. So this is the equation of the distance of the truck as a function of time. For the automobile, d sub a, the same formula, but d sub a is this distance. Since we take this point on the truck as x equals 0, the expression for the distance is d sub a plus 44.32 meters equals the expression at the right side, where b sub o is equal to 0 since the automobile starts from rest, with the acceleration is 3.5 meters per second squared. Simplifying, solving for d sub a, so we have this function distance traveled by the automobile as a function of time. So we are going to plot the graph of these two equations for the position of each vehicle as a function of time. So these are the graph of these two equations. For the red one, for the truck, the graph of the equation d sub t equals 1.1 t squared. So this graph is the graph of distance against time. The blue graph is the graph of this equation d sub a for the automobile equals 1.75 t squared minus 44.32. The point of intersection between the two graphs, this point has coordinates 8.26 seconds and 75 meters. So this is an instant where the two vehicles were abreast. They are abreast at time t equals 8.26 seconds. This point, so this distance negative 44, negative 44.32 is the distance where the automobile and the truck are separated initially. Problem number 2. You are on the roof of the P6 building, 46 meters above the ground. Your P6 professor, who is 1.80 meters tall, is walking toward the building at a constant speed of 1.20 meters per second. If you wish to drop an egg on your professor's head, where should the professor be when you release the egg? So here is our problem. And the egg will travel this height exactly at the head of the professor. This height, the building is 46 meters, so 46 meters minus 1.8, so this height is 44.2 meters. The height where the egg is dropped. We have here the equation of uniformly accelerated motion. We will use equation number 2 for the height, y. The egg starts from rest, so this is equal to 0. The height is taking the starting point as the origin, so downward is negative, so negative 44.2. Acceleration due to gravity is directly downwards, so negative 9.8. So simplify the equation and solve for t. Divide, then extract the square root of both sides of the equation. So t is equal to 3 seconds. The time it takes for the egg to fall up to this point is 3 seconds. In other words, the professor must be walking within 3 seconds to reach this point. So from distance formula, the professor is not accelerating, so this term is 0. So distance is equal to speed times time. The professor is walking at 1.20 meters per second times the time it takes from this point to this point is 3 seconds. So the distance is 3.6 meters. In other words, it takes 3 seconds for the professor to walk this distance, 3.6 meters, so that at this point, the egg is exactly dropped on the professor's head. Problem number 3. A student is running to catch the campus shuttle bus which is stopped at the bus stop. The student is running at a constant speed of 6 meters per second. She can't run any faster. When the student is still 60 meters from the bus, it starts to pull away. The bus moves with constant acceleration of 180 meter per second squared. A. For how much time and what distance does the student have to run before she overtakes the bus? When she reaches the bus, how fast is the bus traveling? C. Sketch a graph showing x as a function of time for both the student and the bus. Take x equals 0 as the initial position of the student. So this is our problem. The student is going to catch up the bus which is 60 meters. Then she moves with constant speed of 6 meters per second. The bus starts from 0 and its acceleration is 0.18 meter per second squared. So after some distance, the student is able to catch the bus. So this is our equation for uniformly accelerated motion. Letter A. So let us consider the distance the student has to run. So from equation number 2, the student is not accelerating, so acceleration is 0. So this is the distance traveled by the student. This distance of the student is equal to 60, but the distance is equal to, but this distance, this sub is equal to the sum of these segments, 60 plus x. Then from this equation, let us solve for x in terms of t. This is our equation 1. For the bus, equation number 2, the bus starts from rest, so initial speed is 0. Its acceleration is 0.18 meter per second squared. Simplify the equation. So this is our equation number 2. Let us equate equation 1 and 2. So this is our equation, equating equation 1 and 2. Let us arrange the equation in a standard quadratic form. Then solve for t using quadratic formula. Substitute the value of a, b, and c. Then simplify. One value, t sub 1 is 12.25 seconds. The other value, t sub 2 is 54.42 seconds. So there are two time intervals wherein the student can catch up the bus. Its corresponding distance x sub 1. Substitute t sub 1, 12.25 seconds. So x sub 1 is 13.5 meters. Substituting t sub 2, 54.42 seconds. So x sub 2 is 266.52 meters. In other words, the total distance traveled by the student is equal to, corresponding to t sub 1, 12.25 seconds, d1, d sub 1 is equal to 60 plus 13.5 meters is equal to 73.5 meters. D sub 2 corresponding to t sub 2 is equal to 60 plus 266.52 meters. The distance traveled during this time is 326.52 meters. Letter B. When she reaches the bus, how fast is the bus traveling? So equation number 1 for the speed of the bus. So the bus starts from rest, so this is 0. And its acceleration is 0.18. The time t sub 1 is 12.25 seconds. So the speed of the bus at time t1 is equal to 2.2 meters per second. At the second time interval, where the time t sub 2 is 54.42 seconds, the speed of the bus is 9.8 meters per second. For letter C, let us plot the graph of the distance against time for the motion of both the student and the bus. So the red one is the graph of the equation for the motion of the student. The blue graph is the graph of the equation for the motion of the bus. Take note that at one point, the coordinates is 12.25 seconds and 13.5 meters. This is the first time where the student were able to catch the bus. And the second point with coordinates 54.42 seconds and 266.52 meters is the second time interval wherein the student can also catch up the bus. This point, negative 60 meters below the origin, is the distance to which the student is behind the bus. Considering the equation of the bus, if we are going to take the derivative of x with respect to t, so the derivative is 2 times 0.09. Then substitute t sub 1, 12.25 seconds. And we know that dx dt is the speed of the bus and it is equal to 2.2 meters per second. While substituting t sub 2, which is 54.42 seconds, simplifying, dx dt is the speed of the bus, which is 9.8 meters per second. Problem number 4, the driver of a car wishes to pass a truck is traveling at a constant speed of 20 meters per second. The car initially is also traveling at 20 meters per second. The car's maximum acceleration in this speed range is 0.80 meter per second squared. Initially, the vehicles are separated by 25 meters and the car pulls back into the truck's lane after it is 25 meters ahead of the truck. The car is 5 meters long and the truck is 20 meters long. The car's acceleration is a constant 0.80 meter per second squared. A. How much time is required for the car to pass the truck? B. What distance does the car travel during this time? C. What is the final speed of the car? So here is our problem. Both the car and the truck initially moving at 20 meters per second. They are separated initially by 25 meters. And the length of the car and the length of the truck. After some distance the truck has traveled, the car overtakes it until the car is 25 meters ahead of the truck. So here is our equation of uniformly accelerated motion. Let us consider the motion of the car from point A to point B. The length from point A to point B is equal to the sum of these segments. 25 meters plus 20 meters plus 20t plus 25 meters plus 5 meters. Now for the motion of the car, let us use equation number 2 for distance traveled by the car. The initial speed of the car is 20. Its acceleration is 0.80. So this is the expression for this distance traveled by the car from point A to point B. This equation, rather, the distance traveled by the car must be equal to this length. So let us equate these two equations. Then let us solve for t in this equation. So cancel out common term on both sides of the equation. Then simplify, combine similar terms. Then solving for t squared, divide and extract the square root on both sides. So t is equal to 13.7 seconds. In other words, the car takes 13.7 seconds to reach point B. The car takes 13.7 seconds to reach from point A to point B. Next, the distance traveled by the car, this distance from point A to point B is equal to Initial speed is 20, time is 13.7 seconds, acceleration is 0.80, and time is also 13.7 square. Simplifying the equation, so the distance traveled by the car from point E to point B is 349.08 meters. Next, what is the final speed of the car? From equation number 1, the final speed of the car is equal to initial plus acceleration times time. Initially, it is moving at 20, acceleration is 0.80. Multiply and simplify, the car speed at point B is 31 meters per second. Problem number 5, a football is kicked vertically upward from the ground, and a student gazing out of the window sees it moving upward past here at 5 meters per second. The window is 12 meters above the ground. And A, how high does the football go above ground? B, how much time does it take to go from the ground to its highest point? So, here is the problem. The height on which the ball is seen is 12 meters, and it is observed to be moving upward at 5 meters per second. We have here the 3 equations for uniformly accelerated motion. First, we need to determine the initial speed it is being thrown upward. From equation number 3, with D as the height, at this point, B sub y, the final speed is 5 meters per second. Substitute. An acceleration due to gravity is negative 9.8. Y is 12. So, from this equation, we will solve for the initial speed. Simplify, combine, and extract the square root on both sides. So, the initial speed, the football is kicked vertically upward is 16.13 meters per second. The initial speed of the ball. Next, at the highest point, the speed of the ball, the final speed is equal to 0. So from equation number 3, final speed is 0. The square of the initial speed is 260.2. Substitute acceleration due to gravity and solve for y in this equation. Divide both sides by the coefficient of y. So the value of y, the highest point reached by the ball is 13.3 meters. How much time does it take to go from the ground to its highest point? So from equation number 1, final speed at the highest point is 0. Initial speed is 16.13. And acceleration due to gravity is negative 9.8. Solve for t in this equation. Simplify. And divide. The time it takes for the ball from the ground to the highest point is 1.65 seconds.